Welcome to Fluxpill. Somewhere above you right now, possibly within miles of where you are sitting, there may be an aircraft that you cannot see, cannot hear, and cannot detect on radar. An aircraft that looks like nothing else in the sky. An aircraft that cost more per unit than any flying machine ever built in the history of human aviation. An aircraft so expensive, so technologically demanding, so extraordinarily difficult to maintain and operate that the United States Air Force could only afford to build 21 of them and has lost one in a catastrophic accident that left the American military staring at a smoking crater in Guam, knowing that what just burned represented $2 billion of national treasure and decades of classified engineering that cannot simply be replaced. This is the B-2 Spirit stealth bomber, and its story is one of the most extraordinary intersections of physics, engineering ambition, Cold War paranoia, and breathtaking fiscal excess in the history of American military technology. At approximately $2.1 billion per aircraft, the B-2 is not just the most expensive bomber ever built. It is the most expensive aircraft per unit in the history of powered flight. Period. More expensive than any fighter jet. More expensive than any surveillance platform. More expensive than Air Force One. A single B-2 Spirit costs more than the gross domestic product of some small nations. And the Air Force will tell you, without hesitation, that it is worth every single dollar. Today we are going deep inside the B-2 Spirit. The physics that make stealth possible. The engineering decisions that made this specific aircraft the shape it is. The extraordinary cost of maintaining a machine that requires climate-controlled hangars. Thousands of hours of specialized maintenance per flight hour, and a workforce of cleared technicians who understand systems that most of the aerospace industry has never been allowed to see. And the question that has haunted the B-2 program since its first public appearance in 1988. Is a $20 billion fleet of 20 aircraft actually a rational defense procurement decision, or is it the most spectacular example of Cold War defense spending excess in American history? Let's begin. The B-2 Spirit exists because of a very specific fear that gripped American military planners in the late 1970s and early 1980s. Not just the general fear of Soviet military power, which had been the background radiation of American defense policy since 1945, but a specific, technically grounded fear about what Soviet air defenses had become. By the late 1970s, Soviet surface-to-air missile systems had evolved far beyond the relatively simple technology that American aircraft had faced in Korea and even Vietnam. The S-75, the SA-2 system that had caused devastating losses over North Vietnam, was now supplemented, and in many cases replaced by far more sophisticated radar-guided systems. Soviet radar networks had become extraordinarily dense and overlapping, with multiple independent systems covering the same airspace from different angles and making the electronic jamming and evasion techniques that American aircraft had relied upon increasingly unreliable against a near-peer adversary. The conclusion that American planners reached was direct and uncomfortable. In a conventional conflict with the Soviet Union, penetrating Soviet airspace to strike strategic targets with conventional bombers, even sophisticated ones like the B-1, would result in catastrophic losses. The Soviet air defense network had, by informed assessment, become genuinely capable of shooting down virtually everything the United States Air Force could fly at it in quantity. The answer to this problem was not faster aircraft, because radar can track speed. It was not higher flying aircraft, because radar can track altitude. The answer, developed from foundational physics work and tested in earlier programs like the F-117 Nighthawk, was to make aircraft that radar could not see in the first place. Stealth, the ability to reduce an aircraft's radar cross-section to the point where it effectively disappears from enemy detection systems, not by jamming those systems or flying around them, but by absorbing or redirecting the radio frequency energy those systems emit before it can bounce back to the radar receiver. To understand why the B-2 looks the way it does, you need to understand how radar actually works and what specifically makes an aircraft visible to it. Radar systems work by emitting radio frequency energy in the direction of interest and then listening for echoes. The transmitter sends out a pulse of radio energy. That energy propagates outward, and when it strikes an object, a portion of that energy reflects back toward the radar receiver. The receiver detects the returning echo, measures the time it took to arrive, and calculates distance and direction. The strength of that echo, the amount of energy that returns to the receiver, is quantified as the radar cross-section of the target object. A conventional aircraft is a terrible stealth vehicle because virtually every design choice made for aerodynamic and structural reasons happens to also be an excellent radar reflector. Large flat surfaces at right angles to each other create corner reflectors, which bounce radar energy directly back toward its source with extraordinary efficiency. Engine inlet openings create radar energy traps, reflecting energy into the engine and then scattering it in unpredictable directions. Vertical tail surfaces create large, nearly perpendicular radar reflecting planes. Metal fasteners, panel gaps, and external weapons create thousands of small but cumulative radar reflection points. A conventional military aircraft can have a radar cross-section equivalent to a large bird or even a large flying object, thousands of times its actual physical size, depending on viewing angle. Reducing that radar cross-section to something resembling a small bird or a metal marble, or in the most extreme cases a large insect, requires attacking every single one of these reflection mechanisms simultaneously through a combination of geometry and materials. The geometry of the B-2 represents the first and most fundamental stealth design principle, the flying wing configuration, where the aircraft is essentially a single continuous wing shape with no fuselage, no vertical tail surfaces, and extremely limited perpendicular surfaces, eliminates many of the most significant radar reflection features of conventional aircraft design. There are no tail surfaces bouncing radar energy back at the emitter. The leading edge is carefully swept at a specific angle so that it redirects incoming radar energy to the sides rather than back toward the emitting radar. The trailing edge uses a W-shaped serrated design for the same reason. Every external surface of the B-2 is designed so that radar energy striking it is deflected away from the direction it came from rather than returned to the emitter. But geometry alone is not sufficient to achieve the extraordinary stealth performance the B-2 was designed for. The surfaces themselves, even if shaped correctly, will still reflect some radar energy simply because they are physically present objects. This is where the second major technology category of stealth engineering becomes critical: radar-absorbing materials. The outer surface of the B-2 is covered with specially formulated radar-absorbing material coatings, highly classified composite and chemical formulations that convert incoming radar energy into heat rather than reflecting it. The specific formulations of these materials are among the most closely guarded secrets in the American defense establishment, but the underlying physics principle is relatively straightforward. The materials contain carbon-based compounds and other substances with specific electromagnetic properties that cause the radar energy to be absorbed and dissipated as thermal energy as it penetrates the material, rather than being reflected from the surface. Multiple layers of different materials may be stacked to absorb radar energy across different frequency ranges, providing broadband stealth performance against the wide variety of radar systems an adversary might employ. The maintenance requirement for these coatings is one of the primary drivers of the B-2's extraordinary operating cost. The radar-absorbing material is sensitive to temperature, humidity, precipitation, and physical contact. Every flight in adverse weather conditions, every maintenance action that touches the external surface, every expansion and contraction of the underlying structure as temperature changes can degrade the coating's performance. After every mission, maintenance crews must carefully inspect the entire external surface of the aircraft, identifying areas where the coating has been damaged or degraded, and apply repairs using materials and processes that are themselves classified. The B-2 cannot be left parked in the rain like a conventional aircraft. Each aircraft requires a dedicated climate-controlled hangar at Whiteman Air Force Base in Missouri, the B-2's home base, specifically designed to maintain the temperature and humidity conditions that preserve coating integrity. These maintenance requirements translate directly into operating cost numbers that seem almost impossible to believe even in the context of military aviation generally. The B-2's cost per flight hour has been reported at various points in its history at figures ranging from approximately $130,000 per flight hour to estimates that reach significantly higher when full program costs, including maintenance facility, operations, workforce costs, and specialized material supply chains are included in the calculation. For context, the F-22 Raptor, itself an extremely expensive and complex aircraft, has reported operating costs of approximately $68,000 per flight hour. The B-2 is not merely expensive to operate. It is in a cost category of its own. The original acquisition program envisioned a fleet of 132 B-2 aircraft, with some early projections suggesting as many as 200. These numbers were developed during the Cold War, when the Soviet threat justified almost any expense in the minds of defense planners and the congressional committees that funded the military. The per-unit cost at that production volume, while still very high, would have been substantially lower because the enormous fixed development costs of the program would have been spread across a much larger number of airframes. Then the Cold War ended. The Soviet Union collapsed in 1991. And suddenly, the political and strategic calculus that had justified a fleet of over 100 stealth bombers looked very different to a Congress and a public that wanted a peace dividend, not a $100 billion stealth bomber fleet. The B-2 program was cut repeatedly as the strategic threat environment changed, from 132 aircraft to 75, then to 40, then to the final number of 21, the number that had actually been funded and were either completed or in various stages of construction. 21 aircraft, with the full development cost of the program now spread across only 21 airframes instead of the 132 originally planned, producing the staggering per-unit figure that has made the B-2 famous beyond its military capabilities. One aircraft, named the Spirit of Kansas, was lost in February 2008 when it crashed during takeoff from Andersen Air Force Base in Guam, due to moisture in the aircraft's air data sensors, causing erroneous data that led to a pitch-up and departure from controlled flight on the takeoff roll. Both crew members ejected safely. The aircraft was destroyed. The Air Force was left with 20 operational B-2s, a number that has remained unchanged since. The aircraft that survived that reduction have deployed to combat on multiple occasions. B-2s flew combat missions in Kosovo in 1999. The first combat use of the aircraft, flying nonstop round-trip missions from Whiteman Air Force Base in Missouri to targets in Serbia and back, missions that lasted approximately 30 hours and required multiple aerial refueling contacts. They deployed to Afghanistan after the 11th of September 2001. They conducted strikes in Libya in 2011 during Operation Odyssey Dawn, and they have been maintained in a constant state of readiness since, representing one of the most significant elements of American conventional strike capability against the most heavily defended targets on Earth. The Nonstop mission profile, enabled by aerial refueling, represents one of the B-2's most operationally significant characteristics. Because the aircraft can be refueled in flight, its effective range is essentially unlimited. A crew of 2 pilots can theoretically strike any target on Earth from Whiteman Air Force Base without landing, given sufficient tanker support. This global reach, combined with the ability to penetrate defended airspace that would be catastrophic for conventional aircraft, gives the B-2 a capability that American military planners describe as irreplaceable, regardless of cost. The B-2 carries a significant conventional and nuclear payload. Its internal weapons bays, which maintain the aircraft's external stealth profile by keeping all weapons carried internally rather than on external pylons, can carry up to 40,000 pounds of munitions. This includes conventional precision-guided bombs, including the massive ordnance penetrator, a 30,000-pound bunker-busting weapon specifically designed to defeat deeply buried and hardened targets the kind of target that would be essentially impervious to most other aircraft-delivered munitions. The nuclear role includes B-61 and B-83 gravity bombs, and the B-2 is planned to be certified for the upgraded B-6112 nuclear gravity bomb as part of ongoing nuclear modernization programs. The question of whether the B-2 program was worth its extraordinary cost is one that defense analysts, budget experts, and military historians have been arguing since the program's cost became publicly known in the late 1980s. The critics argue that the resources consumed by 21 aircraft could have funded a much larger fleet of capable but less exotic aircraft, or provided funding for other military priorities. The defenders argue that the B-2 provides a unique capability that no other aircraft can replicate, specifically the ability to penetrate the most sophisticated air defense systems on Earth and deliver precision munitions to targets that would otherwise require nuclear weapons to threaten, providing a conventional deterrence capability of strategic value that cannot be evaluated purely in per-unit cost terms. What is certain is that as Chinese and Russian air defense capabilities have continued to improve in the decades since the B-2 entered service, the underlying strategic logic that drove its development has become, if anything, more rather than less relevant. The advanced integrated air defense systems now operated by potential adversaries represent threats that the B-2's designers would have recognized immediately as exactly the kind of environment the aircraft was built to penetrate. And the next-generation stealth bomber, the B-21 Raider currently in development and early production by Northrop Grumman, represents the Air Force's determination that stealth-penetrating capability is not a Cold War relic, but an enduring strategic necessity. The B-2 Spirit will eventually be replaced by the B-21. But for now, 20 aircraft sit in their climate-controlled hangars at Whiteman Air Force Base, their coatings carefully tended, their systems constantly maintained by a workforce of specialists cleared for some of the most sensitive technology the United States government possesses. Ready to fly anywhere on Earth, ready to strike anything on Earth, and essentially invisible to the radar systems that would try to stop them. 20 aircraft. $20 billion. The most expensive fleet of flying machines in human history. And possibly the most valuable 20 aircraft the United States Air Force has ever owned.